Our first objective is to identify an appropriate point estimator and calculate the value of a point estimate. So the estimator, that's going to be p hat x bar s. The point estimate is the actual value of the statistic that you're using. So they want us to identify the point estimator you would use to estimate the parameter in each of the following settings and calculate the point estimate. So our first example, a quality control inspector wants to estimate the mean lifetime mu of AA batteries produced each hour at a factory. They select a random sample of 50 batteries during each hour of production and then drain them under conditions to mimic normal use. Here are the lifetimes in hours of the batteries from one such sample. So we have 50 batteries represented here in our simple random sample. So the point estimator, to estimate mu, our point estimator is going to be a sample mean x bar. There we are. So the point estimator is x bar to try and estimate the population mean mu. The point estimate is the actual value of x bar. So what we'd have to do is we would have to add all these together and then divide by 50. And so we would get a point estimate of about 16.178 hours. And you can see you should know how to take the mean of a sample here. You can type these in list one and do one variable statistics, or if you want, you can add them all up and divide by 50. But this is just to remind you that the point estimate is the actual value, 16.178 hours. The estimator is x bar. Problem B says, what proportion of US adults would classify themselves as vegan or vegetarian? A Pew Research Center report surveyed 1,473 randomly selected US adults. Of these, 124 said they were vegan or vegetarian. So you could ask yourself, is this a categorical variable or is it quantitative? Well, they fall into a category of being vegan or vegetarian, so this is categorical. So we're going to estimate a proportion here. They want to know what proportion fall into these categories. So our estimator, our estimator is going to be p hat because we want to estimate the population proportion. The point estimator is going to be p hat to try and estimate the population proportion, p, and the point estimate is the actual value of the sample proportion. So we had 124 that were out of 1,473. Our point estimate is 0.089. So this is our best estimate of the population proportion, but you got to remember it's not going to be exactly equal to, so that's where the margin of error will start to come in. We'll stretch out a little bit from our point estimate to try and increase our confidence of actually estimating the population proportion. So the last example, the quality control inspector in part A wants to investigate the variability in battery lifetimes by estimating the population standard deviation. So we're using the battery life again, but this time they want to estimate the population standard deviation. So our point estimator will be the sample standard deviation, and our point estimate will be the value of the sample standard deviation. Again, the point estimator is the sample standard deviation to estimate the population standard deviation, but the point estimate actually is the value of the sample standard deviation. So again, our sample was up here in this previous problem. You'd have to type these in list one and then do one variable statistics and it will tell you the sample standard deviation, or you can use the fun standard deviation formula if you'd like to. In this next part of the video, we're going to look at three objectives at once here. So the first is to determine the point estimate and the margin of error from a confidence interval. And we're going to use a confidence interval to make a decision about the value of a parameter. And then we're going to interpret the confidence interval in the context of the problem. So just a reminder that a confidence interval gives an interval of plausible values for a parameter based on sampled data. So the word plausible, it does not mean possible. They don't mean the exact same thing. Plausible means we shouldn't be surprised if any of the values in the interval is equal to the value of the parameter, which is not the same thing as all possible. To interpret what a confidence interval is, we're going to say, so C represents the level of confidence because our level of confidence can change. We could be 90% confident, 95% confident, 99% confident. So this will change based on the level of confidence that you want. But we would interpret, um, let's just say for this case, 90% confidence interval. To interpret a 90% confidence interval for an unknown parameter, we would say we are 90% confident that the interval from blank to blank captures the actual parameter of the population in the context. So it's really, if you're asked to interpret a confidence interval, it's just a copy paste statement here where you're changing the level of confidence and you're changing the actual values of the interval because they won't always be the same. So let's look at an example here. I guess before I move to the example, you do need to know that interpreting a confidence interval is different than interpreting a confidence level. We're going to talk about interpreting a confidence level later in this video, but right now we're interpreting what the actual interval itself means. So, example 2. 2 weeks before a presidential election, a polling organization asked a random sample of registered voters the following question: if the presidential election were held today, would you vote for candidate A or candidate B? Based on this poll, the 95% confidence interval for the population proportion who favor candidate A is 48% to 54%. So they've told us this is a 95% confidence interval. It's 95 for this problem, but in the future problems, they might tell us it's 90% or 99%. The level of confidence, which is this, can change. So our actual interval is from 48% to 54%. Interpret what this means. So this is where the fill in the blank statement comes into play. We're 95% confident the interval from 0.48 to 0.54 captures the true proportion of all registered voters who favor candidate A in the election. Okay, again, they tell us that the 95% confidence interval is for those who favor candidate A. So that's why our population parameter we're interested in is the proportion who are favoring candidate A. We're using the sample that they took to estimate the population proportion, which is unknown. The actual proportion who favor candidate A. All we have is the sample that they took and asked who they favored. So they're using this to estimate the overall population. Now, one thing I need to make sure I say is that when you're interpreting a confidence interval, it's really important that you describe the parameter and not the statistic. For example, the statistic would be the midpoint here that they took. And we're not describing the statistic, we're trying to capture the population of voters, of all voters who favor candidate A. So make sure you're interpreting a confidence interval, you describe the parameter and not a statistic. Next question, what is the point estimate that was used to create the interval? What is the margin of error? So if this is our interval, we know the point estimate will be the midpoint here, and the margin of error will be the distance from the midpoint to the upper or the lower. As we saw earlier in the video, this picture might help clarify. They tell us that the confidence interval goes from 0.48 to 0.54. So the point estimate will be the middle or the center of this interval. The margin of error is this distance here, which is the same as this distance here. So find the midpoint and then find the distance from here to here, and that will answer both the point estimate and the margin of error. To find the midpoint, add the lower and the upper and divide by 2. That will give you a midpoint of 0.51. So that's our point estimate. And then just subtract 54 minus 51 to get the margin of error of 0.03. Okay, so last question. Based on this poll, a political reporter claims that the majority of registered voters favor candidate A. Use this confidence interval to evaluate the claim. So you have to remember that a confidence interval gives us all plausible values. So in our interval, we stretch from 0.48 or 48% to 54%. So we believe, we're 95% confident that the proportion of voters who favor candidate A is somewhere from 48% to 54%. So based on what we believe to be true, what do we think about this claim? A political reporter claims that a majority. So if it was a majority, that would mean it has to be more than 50%. And based on our interval, we can't say that that's true. Yeah, there are some values that are greater than 50%, but there are also values that are less than 50%, 0.48, 0.49, and anything between 0.49 to zero point 0.5. So these are plausible values. We believe that these could be values. Now, yes, we also believe that there could be values greater, but we don't have enough evidence to say it's definitely a majority because there are some values that are less than 50%. So because there are plausible values of p less than or equal to 50% in the confidence interval, the interval does not give convincing evidence that a majority of registered voters for candidate A. Just to clarify on this sentence, because there are plausible values of p. So remember, p is the population parameter, which in this case is the proportion of all voters who favor candidate A.